good afternoon, and thank you everybody for joining us for our webinar today. The title of our session today is Outsmarting the Bots, and this will be jointly presented by Cynozure and Veracity Trust Network. Really exciting topic we've got for you today. Just a few intros then to our brilliant panel. I'll be hosting today's session. My name is Sophie, for those of you who don't know me. And I can't get us onto the next slide. There we go. My name is Sophie, for those of you who don't know me. I am Business Development and Community Growth Specialist for Cynozure, but today, specifically, my role is to moderate our session, make sure everything runs as smoothly as possible. Our brilliant presenters for the next hour will be Stewart, CTO for Veracity Trust Network, and Tom Wilson, Solution Architect here at Cynozure. And I know they've got lots of experience to share on this topic today. Just before we do dive in then, a little bit of housekeeping. And I know everybody is very used to using Zoom now. So I've only got a couple of comments on this. Please do let us know in the chat where you're dialing in from. It's always really nice to find a little bit more out about our audience and get to know everybody a little better. And we will have some time for questions and answers at the end of our call today. So if you do think of something that you'd like us to address, we do encourage you to pop that in the Q&A box there. So I'll shortly be passing the mic over to Tom and Stewart, but before I do, I would like to take you through a very short agenda. So Stewart will be kicking us off in a few minutes to share his experience in cybersecurity, what it is and why it's so important. We will do a deeper dive into machine learning and the last mile problem. We'll look at the challenge that bots are presenting in cybersecurity and beyond, and why Veracity Trust Network do the work that they do to help organisations overcome those challenges. And then, of course, we're really delighted to share with you the work that we've partnered on together, so Cynozure and Veracity, in terms of forming a solution for that challenge and what the future of that work looks like. As I said, we do have time for questions and answers at the end, so please do keep them coming and we'll try and get through as many as possible at the end of our call today. Now, I know some people on this call may have joined our webinars at Cynozure in the past, but for those who haven't and would like to know a little bit more about us, we are a data and analytics consultancy with people at its core. So our mission is to use data for a better tomorrow and to help all the organisations that we work with do the same. We do that by advising companies on their data strategy, helping them to build the tech, the teams, the processes that they need to deliver business value. And I think this sentiment of using data for good, building a better tomorrow, is particularly relevant for today's session. I know that this conversation of AI, which includes machine learning and automation more broadly, is dominating conversations both in and out of work, on social media, and I'm really excited to share a positive use of machine learning today. So I hope everybody finds it valuable, takes away some good insight for them. And without further ado, I'll be passing the mic to you, Stewart. I know you've got a short intro into your role as CTO at Veracity, and you'll start us off by discussing cybersecurity. Thank you.
Thank you, Sophie, and a pleasure to everyone. Thank you for joining us. Really appreciate you being here. There's a lot of stuff going on that slide, so I'm not going to talk over it other than say that my name is Stewart. I'm the CTO for Veracity Trust Network. We're a 5-year-old company and we focus in cybersecurity and protecting public platforms, which is to say websites, ad platforms, and mobile presence from bots, which we're going to go into. We win a lot of awards for that. We're very good at what we do. Obviously, we're going to say that. But I'm going to start by talking to you about cybersecurity and what it is and perhaps what it isn't and why it matters. So yeah, there's a few things here. So cybersecurity, as it says there, is the practice of protecting critical systems and sensitive information from digital attacks. And it's all about people, process, and technology. And if Sophie clicks the thing 3 more times, then you'll see the kind of things that we talk about here. So there's a lot of stuff in people in terms of behaviors, how people behave, having appropriate staffing levels. Process is very important to it because it's all about repeatable process, which is really important when you're dealing with things like disaster recovery or responding to some kind of cybersecurity breach. and then all underpinned by technology. And there's a lot of stuff there. Cybersecurity is very broad in terms of what it does. There's a lot of things that cover cybersecurity. The most secure way to have something on the internet is not to have it on the internet. The most secure way to have something on the internet after that is to put it behind good firewalls, connect it to as few things as you possibly can, ideally within VPNs, but websites, mobile apps, API gateways, things like that can't be treated in that way. They have to be public. They have to be something that's available to people, because that's what you're doing with your website. You want people to come to it. So they're one of the traditionally most difficult ways to protect. Organizations often don't connect them to back-end data sources for that reason, but more and more it's becoming the case that people do and have to. And so they are in many ways kind of the easier target in the cybersecurity space. That's often where a lot of breaches come from or start from, or involve in some ways organizations' websites. So next slide, please. There are dangerous myths around this. There's three bullet points here. And these are really important ones. There's this kind of perception of a cyber criminal wearing a black hoodie against some kind of green lettered matrix background. I mean, unfortunately, if you look for cybersecurity or hacker or something like that on an image platform, you'll see that a lot. And that is true-ish, but it's not utterly true. Very often, cyber breaches have some form of internal source of data or internal source of information, whether it be someone who knows that they're giving away information or someone who doesn't. And quite often, a lot of breaches occur entirely within organizations. Cyber risks are well known, and attack vectors understood and contained, which is just not true. Some cyber risks are well known, some attack vectors are understood and contained, but the whole point about cybersecurity is there's a genuine desire amongst people who are carrying out these activities to find new ways to break into systems and to steal data and to frankly make money. And they're very incentivized to do so. And we'll talk about some of the potential revenue that people can make out of this kind of thing later. And also we get this a lot, particularly in certain sectors. If there's any fintech people on here, apologies, but your sector is sort of hubris in it around being safe and being secure because you know everything that could possibly attack you. Well, that's just not true. And again, we'll have a few examples in coming slides. So Sophie, thank you. So a few stats, and I'll build upon these. So data breaches, according to the NCSC, cost up over £130,000 sterling to fix. Obviously, you can translate into any currency you want. There's stats around America. Rather embarrassing, I was at an NCSC event last week in Belfast, and I was quoting their own stats back at them, but they didn't laugh at me, so I must have got them right. It's really important because, not besides obviously the pure cost of some form of data breach or data loss, a lot of people are put off working, a lot of consumers are put off working the business that's been the victim of a website compromised data breach. And it's also worth saying, and I don't think there was a slide on this, but again, according to the NCSC, 60% of small businesses that are victim of a data breach go out of business within 6 months. And that's that, because I mean, partly that's because of the pure cost. £130,000 is a lot of money for most organisations to absorb out of nowhere that they have to spend. But also, you get the lack of confidence in their consumers and their prospects. This was a really nice piece of research by HSBC, looking at the underperformance of NASDAQ listed companies following a data breach announcement. You can see over a 3-year period, it was their performance was down by 15.6% versus their peers. So it affects companies small and large, and therefore it should be a really big deal, but isn't always. I'll just give you a couple of stats from the 2022 UK Government Cybersecurity Breaches Survey. 8 out of 10 businesses that responded reported cybersecurity as a high priority for their senior management, yet only 1/3 of businesses had any kind of board responsibility for cybersecurity. So you've got that mismatch between people saying, yes, we'll do this, take it seriously, we care about these things, and actually a lack of buy-in at a senior level, which means that you don't get budgets for this kind of thing. Cybersecurity budgets tend to have to fight for their position amongst sort of more operational budgets, more technology budgets, and only 17% of businesses take any form of cyber vulnerability audits, which is a priority stance, and less than 10%, about 7%, actually do any supply chain risk analysis, which is really important. There was a very recent breach of people like BBC and Aer Lingus and Boots and others, which was carried out through some HR software. which stole a lot of data from those organizations, and it came in from a, as it turned out, not secure file transfer system within the HR system. And that's what we talk about supply chain, looking down your supply chain and saying, where are breaches coming? Where can I be impacted by those? So cybersecurity is a big thing. Most organizations don't take it very seriously. I hope I haven't depressed you too much. Next slide. Oh, there we go. I can't remember these slides. So that's what I'm talking about there. So the British Airways, Aer Lingus and Boots, that was the hack I was talking about. And if you scan that QR code, you'll be able to go and look at the LinkedIn post. Said that already. So suspended companies out of business. And I think this is possibly my last slide before Tom picks up a little bit. Cyber attacks set to become uninsurable, says Marco Greff, I think his name is the Zurich CEO. He said this in the Financial Times last Christmas, and he was saying in response to Lloyd's of London, which is the primary reinsurer in the UK, who last summer told those writing in cybersecurity breaches to remove coverage for state-backed attacks, which is a really big deal. So it's basically limiting systemic risk from cyber attacks that are state-backed. Most organizations, most hacking organizations have some kind of affiliation into state, because to be effective what you do, you need money, and it's an expensive job. I think there may be one more slide. Is that right? Sorry, apologies. Yes, here it is. Yes. And the reason this is relevant, if you click twice more, please, you'll see two numbers there, 250%. So the increase in the attacks on Ukrainian individuals and organizations since the beginning of the Russian invasion of Ukraine by Russian-backed or affiliated hacker groups is up 250%. Against NATO organizations and individuals is up 300%. And that's why Lloyd's of London moved to limit systemic risk in that area, because obviously it's suddenly become a very big deal. And what the Zurich CEO was saying was that actually cybersecurity in itself may become uninsurable very soon for most organizations. So taking it seriously, very big deal.
It's really important. Thank you, Stuart. And I think I certainly didn't realise the impact of it. So thank you for sharing that with us. I know that we're going to come back to some of these stats later on. But for now, Tom, are you able to tell us a bit more about machine learning?
Of course, yeah. Thank you, Stuart. Thanks, Sophie. So yeah, my role in all this as a data scientist is to take these problems and to work out some technical solutions for them. And so we've been working with Veracity very closely on deploying machine learning, or using machine learning to help outsmart the web bots. So I want to kind of just talk to you for a few minutes about what machine learning actually is, how do we use it, what some of the methods are, and give you some examples of some other big companies that I'm sure you've all heard of, and how they use machine learning in their day-to-day business lives to drive value. So I think the first thing I would like to broach is something I always talk about when I think about machine learning, is the difference between ML and AI. So you might hear a lot of the time, sometimes we do it as well in conversation, but ML and AI tends to get bandied about interchangeably as a terminology. And although they are related very closely, they are two kind of quite different things. So artificial intelligence, is more the umbrella term to describe how a computer mimics the cognitive behaviors, things like recognition, learning, and problem solving of a human being. It's kind of this larger, broader discipline of which machine learning is one. So machine learning is the process itself of using mathematical models and code to build algorithms that learn from data and make predictions without being explicitly told how to do so. So that's, as you can see, machine learning is very much a subset of AI, but they aren't the same thing. And so machine learning has a broad range of techniques that we can employ in various different scenarios. So the three here you can see across the discipline. Supervised machine learning on the left is probably the one that is made most common in terms of its use. This is a task-driven approach where the model learns from the correct outcomes it's been given during training, labels of true, false, etc. And then it predicts the next value. So the two methods here most commonly used are classification. So when you teach it how to classify something, is that a dog, is that a cat, is this true, is this false, etc. And then the other method is called regression, which is where you teach the model to predict a continuous variable. So things like forecasting is probably the most common use of that. Unsupervised learning is another sort of discipline of machine learning. It's a data-driven approach where the model doesn't know the outcomes of the data it's being analyzed. So there's no labels associated with it, and it's really looking to identify patterns and clusters in the data. So probably the most common uses of this will be things like customer clustering, customer segmentation in looking at web behaviors, and anomaly or outlier detection in sort of financial or any sort of data which requires looking for anomalies or anomalies in that data set. And then the final one is reinforcement learning, which is probably the most complex and probably the most kind of current in terms of like how it's used in many applications. This one is an outcome-driven approach. It learns, quite crucially, the model learns from its mistakes. So the model itself does not rely on static data sets like the previous two do. Instead, it collects data experiences dynamically, and which means, you know, the advantage there is data doesn't have to be collected, pre-processed, or labeled in many scenarios. But the model will just learn from it, and it crucially learns from its mistakes as well. So it reduces the level of human interaction required to manage the model and enables the model to kind of get better continually over time. It's a really popular methodology, one that is used quite heavily in ChatGPT, which I think is everyone's favorite use of machine learning and artificial intelligence at the moment. So, you know, that uses itself quite powerful deep learning algorithms based on a reinforcement learning model. And so that's kind of the background of the processes and what machine learning is. And now we want to talk to you about a few practical uses of that. And so you can see on the slide here, we've got a number of household names. I'm sure everyone has heard of a lot of these. And so all of these companies use machine learning quite extensively in their business models. So Netflix, for example, I think we're all very familiar with Netflix and how it works. But Netflix has obviously got a very, very, very strong recommendation engine for its content. Very important to get this right for Netflix, as when they first started out, they didn't have the huge library of brilliant content or like licensed content that they have now. They had to be very, very shrewd and be very good at selecting what they thought a customer would want to watch next, because they didn't have the volume that they have now. Spotify is kind of the same. They again, as they started out, they did not have the huge volumes of music they have now, so they had to become very good at curating playlists and presenting customers with the music they wanted to hear based on their listening history. So these are both really good practical uses of machine learning in business. And of course, you know, Tesla, I think we're all very familiar with Tesla and the company and the man who owns it. But in terms of what they do, probably one of the most interesting things they do is their constant striving towards improving self-driving car technology or automated car driving, which is, you know, an incredibly complex use of machine learning. They use like very, very complicated deep learning neural networks to analyze streams and streams of car data from the various sensors, cameras on the car as you're driving along to help that, you know, to help the models and algorithms learn how to drive. And so this is another great practical example of where reinforcement learning is used, because these things learn from their previous mistake, or they learn from previous incorrect predictions, and they get stronger as they go. So those are kind of three pretty core examples. But I mean, there are others across here, like Lloyds Bank have used it for fraud detection, etc., and all those other things. But one thing these companies have all crucially done is they've managed to take machine learning and apply it into the business as usual life cycle, and actually, you know, gain real business value from that machine learning process. Now, that's not something that every company is able to do, and so it's what we kind of come to term as the last mile problem. Depending on where you look, there are various numbers that suggest this, but around 80 to 90% of machine learning projects that businesses try and push fail to make it into production. And so this is that's what we call, what we're now terming this last mile problem. It's, you know, there's a number of reasons for that. Data itself, you know, is ever changing and fluid. ML models constantly need attention, they need monitoring, and they constantly need to be maintained. And some companies do not have the bandwidth or the knowledge to do that. Actually, they might build a model initially that's really great, but then, you know, as that falls away, the model soon becomes irrelevant and they start to lose confidence in it because the data is changing. The data scientist as a role, I mean, it's very popular as a role in business now, and lots of businesses have them. However, they're very good at doing certain things, building and training machine learning models, but what they might not be so good at is the software engineering best practices that a software developer might have in spades. So, and as we're talking right now, as like deployed and usable applications of machine learning are essentially software applications. So there needs to be a level of knowledge around how that software is maintained, developed, and iterated going forward, and that's not the core wheelhouse of a data scientist. And so the final one really is business leaders themselves, although they're very keen to embrace machine learning techniques and artificial intelligence in general. I think there's still a level of distrust in the techniques that are used, and there is still a level of relying on experience over the data in many cases. They just don't trust the black box that's telling them to stock this many of this t-shirt or this many of that bit of produce, they want to go by gut feel because they know that's what works, and they're just a bit afraid of the new technology. So these are all things that we want to try and overcome, and that's part of the last mile project. And one of the things we've been working with Veracity on in our engagement has been to work through this and address this process so that we don't get stuck in that in the future. So that's, I think, my first intro. I'll just hand back to Stewart, who I believe is now going to talk through why we're doing this with Veracity and why it's important.
Thank you, Tom. Okay, so I mean, just to finish off slightly there, what Tom said. We've known the team at Cynozure, never get it right, for a while now, and we've been wanting to work with them for at least a year. And from our point of view, this was always about building a platform which we would deploy live straight away. So, I'll be honest and say I didn't know anything about the last mile problem whatsoever when we first engaged Cynozure, and I was quite surprised to learn that there's a lot of organizations have that kind of problem. From our point of view, this was a genuine, real problem that we wanted to solve using AI. And that problem is these things here. Now, this isn't a real bot, by the way. A bot is short for software robot. And software robot is nothing other than a bit of software that's been written to do a task with some degree of, well, anything from no to some degree of autonomy. AI itself is starting to be used in the creation of bots and in the sort of self-management, self-awareness of bots. And bots are not per se bad things. There are many good justifications for bots. So Google themselves have bots which navigate around websites and work out what it is a website's trying to talk about when they're thinking about the search listings. And there's whole heaps of these things that are good. But what we're talking about here is malicious bots. So we're talking about malicious bots, and what they tend to doing is they tend to be trying to approach a scenario and making out that they are not what they really are. So they won't come into a situation and say they're a bot. They'll come in and say that they're a human. They'll try and act in a human way. They'll fake their signals around themselves. They'll often fake their geography, where they come from, to look human. And they're doing that for a range of reasons. So next slide. And these are indeed some of those reasons. And what bots are doing is they're basically the foot soldiers in a hacking war, if you will. Bots will be used to try and find vulnerabilities in systems or ways into systems that will then be followed on by one or more human hackers within a group, potentially no doubt supported by tools which include bots. But the bots are the ones that are out there finding vulnerabilities because they're very effective. They're bits of software, they're not humans. And you can see they affect all kinds of industries in different ways. We've all heard about sort of data being stolen, people's personal data being stolen or accounts being taken over. Happens all the time on certain social media platforms. But also creating new accounts, and creating new accounts on a platform means that something starts looking more credible. So if you create an account on, I don't know, for example, a well-known social platform, then that thing that's created the account has markers attached to it that make it look more human, which you can then leverage into creating another account somewhere else, and maybe you take over into someone else's account, and suddenly you create what looks like a well-rounded human being, but is in fact a bit of software. And all of these things here are fundamentally about stealing data that you can sell or you can utilize elsewhere, or they're about stealing content from people. Ticket scalping is one of the things that's in there. Those interested in, for example, the furore around the latest batch of Taylor Swift tickets, where they're being stolen by scalpers, the bots are engaged with that huge, and it happens all the time, and it's very difficult to stop. Ticketmaster basically has utterly failed, again, caveat, self-opinion, not the company's opinion, in the current round of ticket sales. Because straight away tickets are being sold for 10, 100 times their value. And this kind of thing happens in many industries. That's the point. Sometimes people say to us, well, why would this matter to me? What does a bot, what's a hacker got to do with my business? Well, it may well be that the organization you're doing businesses with is of interest to them, so they'll attack you. It may well be that you've got data that is interesting to them because of how it plugs into other data they get elsewhere. So it's a big, interestingly, hacking is really a big data problem. It's perfectly suited to AI in many ways. Next slide, please. Not that I'm suggesting that anyone should try and do that. So OWASP is the Open Web Application Security Project, which is a US-based organization, but it's international. We're just in the process of becoming members ourselves. And they have a number of automated attack vectors that they talk about. I think there's 20 odd. And we do in some of those sectors around automated bot attacks and supply chain attacks. And as it says there, it's very difficult to find sophisticated bots because they deliberately put behaviors into what they do in order to look human. And I'll give you a very good example relating to the mouse movement. Whilst there is no such thing as generations of bots, early bot systems would not fake mouse movement. They would download the DOM, the HTML of a website, and they would interact with elements on it, including clicking on links, but basically navigating to links. And that makes it really easy because people can't navigate around a website without using a mouse, and therefore moving the mouse around or by touching things. And so if you're not seeing those kind of indicators, there's a very strong suspicion you're dealing with a bot. So sort of second and third generation started faking mouse movement and started faking in a more genuine way. And looking at sort of like adding randomness into mouse flow across a page, so it looked like it was a human doing it rather than a bot manipulating their data. And that's one small element of what these things are doing. So next slide, please. And I think we may recognize what this comes from, but the reason this is here, besides being a fantastic visual image, is that it's relating to a thing called MethBot. So a botnet is nothing more than a collection of bots, a network of bots. And basically it's a whole heap of bots, probably hundreds of thousands, not millions, that are being brought together to do one particular thing. In the case of MethBot, what they were doing is they were creating lots and lots of traffic that looks human to thousands of websites created by the owners of MethBot. And those websites were basically premium websites. So they were sort of like purporting to provide information to people interested in buying premium cars or luxury products or whatever it might be. That had, and obviously the content from those were scraped from other places by bots, and then all of this to those websites, which looked like humans with genuine intent to purchase, were bots. I'm sure some humans were in there, but it's primarily bots. And this was all done because the whole programmatic advertising ecosystem that we survive in. So when you see adverts placed on your popular news websites, they're placed by a bit of software that has got ads that it wants to place onto sites with the right kind of audience. And then you've got the software bidding against software to try and say, well, whose ad's going to go where, with programmatic advertising. And these people had a heap load of websites that looked like they were really useful. So what happened is they basically took ads, were paid for taking ads on their websites for well over 18 months. And during the course of the time, just to make you realize the incentive that bot makers have to engage in this, they made up to $3 million a day over 18 months. And that's just a startlingly huge sum of money. People have been arrested in the US. People have gone to prison for this, but not many. And strong suspicion is not necessarily those who are really senior in the organizations. So it's valuable. There's a lot of money in it. And actually, do you know what? It's really, really easy to do. I don't think I've got a slide here which talks about how easy it is, because that's not always something you want to share with an audience. But if you go and search on Google itself for certain terms, you will find on page 1 bot systems that you can use to engage and try and carry out this activity yourself. Simple ones. None, I'm not saying you should, but the point is it's dead easy to do. Okay, next, please. You would genuinely think that people would be taking this seriously. I know, sorry. You generally think that people would be taking this seriously. This is from A Scanner Darkly. Fantastic book and a fantastic movie. But as I mentioned earlier, in terms of the stats we had from the government cybersecurity, so few organizations really genuinely take this seriously. And yet it's a very big deal to them. I'll tell you one other thing you ought to be sort of slightly concerned about right now. It's certainly something that does keep me awake, is quantum computers. Quantum computers is basically a much faster form of computing for certain kinds of things. And one of the things it's going to be really, really good at is breaking cryptography. And when quantum computers genuinely become something that's usable in a non-research way, we're going to find that they basically can crack every form of cryptography and every form of encryption that we have right now. So it's within 10 years, it's possibly shorter. And so we're starting to see now a process of harvest now to crack later activities. It's been noticed by people like the National Institute of Standards and Technology in the US and the Department of Homeland Security, again in the US, who last year released their roadmap for post-quantum cryptography. And that ties in really well with cyber, ties in really well with AI. We have to use tools like AI to detect this kind of activity, because algorithms, rule sets, humans, IP blacklists, all that kind of stuff can't possibly do that. It has to be a process of looking at the behavior of something coming onto a public platform, purporting to be human, and going, you're not a human. And only AI is the only game in town for that. I think that hopefully is my last slide.
Brilliant. Yeah, thank you, Stuart.
Okay.
So we're going to look at the work that Cynozure and Veracity did together now.
Yeah, that's it. So I think it's my turn to jump in. So yeah, all really important. Thanks Stuart for going into that in detail. So we kind of engaged with Veracity quite early on in 2020. Well, before we engaged with them, Veracity ran a short kind of research project with a student from university. They used quite a small scale data set and just generated bot and labeled human data, and they appraised a couple of machine learning methods to see whether they could effectively detect bots, and so that was quite successful. Cynozure, myself and the team engaged with Veracity in early 2022. So we had, at that point, we were brought in to kind of to discuss with Stewart and the team the methodology that had been used by the student to then create a plan for delivering our first iteration, our first version of a machine learning powered bot detection model. And so that's where we started. In 2022 June, we kicked off a short 6-week project with a 3-person team. I led on the data science side of this, and the goal here was to develop, say, a minimum viable product, an MVP for bot detection using machine learning. And so first thing we did was to select one of the models that the research student had done. We actually took a decision tree based model, which was found to be the most effective. Second thing we did was to expand on that training data set, taking a small data set of around 500 records. We expanded up to about 10,000 records, which is much more suitable for training, a practical machine learning model for production use. And then the next thing we did was to actually take a look at the journey data in more detail, the attributes that are on the journey data called features for the model training. There is around 100 of these features, which we managed to cut down and engineer down to around 10 to 15, which were found actually, to be honest, to describe almost 95% of the model's decision-making variance pretty well. So these features, these top 10 features were things like total time spent on the web page, number of pages viewed in a journey, number of actions that were carried out per page, things like mouse movements, as Stuart said, scrolling, touch points, etc. The mouse movements was one of the things we were quite keen and interested to dig into. So what we did in our first version of this was to actually analyze the mouse movements and kind of summarize them per journey. So we'd look at how far the mouse would move, the average time the mouse would take to move, and then from that the speed at which it moved on average. So one of the things that the next steps we might look at in the future is to turn that into looking at the actual tracking shape of the mouse movement, because I think there's a lot of information there around what a bot will do versus what a human will do. And so, yeah, as we went forward, that model was trained, optimized, and evaluated, and we found the model to be pretty good. So the model was about 95% accurate at this point. So if you just click, there's a little chart. That's our, and that sort of shows you the confusion matrix here, which is a common metric of evaluation for a machine learning model. This kind of highlights how well it performs. So we had we minimized our false negatives and false positive response, maximizing true negatives and true positives. So that was a really good result for this initial minimum viable product. One of the things, or a few things that we were quite keen on at this point was in demonstrating how well this would work over kind of a traditional algorithmic approach. One of the things we can do here is we can obviously process this in real time. We can infer a response from the model in real time. We can also look at a sliding scale of prediction here. So it's not just saying, yes, it's a bot, no, it's a bot. It gives us a probability of confidence as to what is a bot and what's not. And also in future, we're looking at adding in the ability to be able to explain why we've given it that score. So a record may have a 95% chance of being a bot, but why is that the case? Well, because the average time spent on the page was this, which is this percentage lower than what we'd expect for a human, and it interacted using these actions in this way, which again differs radically from what we think a human will do, therefore it's a bot. It's adding that level of explainability, which I think clients and customers of the process will find incredibly useful. And so once we've kind of got through that, we expanded the we deployed that as a MVP. We had and then Stuart and the team took this out to trial with a small number of clients. Originally, I think we were looking for 12 volunteer clients. We actually in the end got around 26, I believe, which was an incredibly successful demonstration of this initial version of the technology. And then, so moving on into this year, we re-engaged with Veracity and the team again to kind of to build the next iteration of the ML model. And in this process, we went back in, we retrained the model, which included using a larger data set again with some synthetically created bot data to kind of try and balance out the imbalance between bots and humans in the data set. We refined that feature selection logic a little bit more, added in some more features that have been made available from the new journey that was, say we are obviously iterating this model, but Veracity is also always iterating their data capture. So there were some new features we could include in there, which might be helpful in improving the model as well. Improving our code base and then getting it redeployed back into production so that we could then be once again live classifying classifying web journeys as a bot or a human. So that was how we ended up, how we've been working with the team so far this year. One of the challenges I think that we've been looking at and trying to face at this point is the question of scale. Now, as Veracity continue to expand, more and more clients come on board. This increases dramatically how many journeys there are to score. And so what we've done is we've designed and built the deployment of this around using AWS, Amazon Web Services, cloud services. I mean, that cloud-centric solution has proven to be very cost effective and incredibly flexible and scalable so that our solution can expand to accept the needs of Veracity's business model. And so you actually may have noticed when I talked about the MVP v2 and MVP delivery initially that they're actually the processes there sounded very much like a repeat of themselves, and that's quite true. So a lot of the steps in the ML process and development cycle need to be repeated when every version of a model is deployed. And that's why one of our current work with Veracity is around designing what's called a machine learning operations, or MLOps for short, framework to help really streamline this process for the future. And so MLOps is again very important. So I think if you can go to the next slide, there's a little diagram. So this is MLOps, how we see MLOps at Cynozure. But also it's incredibly important to addressing this last mile problem that we talked about earlier on, this idea that 80 to 90% of projects might fail before they end up in production. And so the framework is really there to lay out the important steps that should be in place to ensure that machine learning projects can be continuously iterated and can continue to add value for a business. So as you see on there, we have steps that look at incorporating exploratory analysis and data processing, looking at designing new models, developing them, training them, optimizing them, making sure that those models are governed correctly, making sure we know which model was used to make which prediction at which time is really important for being from auditing purposes and accountability. Then you go through and look at model service, how the model is served to the customer. Does it need to be a real-time inference? Does it need to be pinged and predictions made in real time, or can it be batched up and made in bulk at the end of the day, for example? These are all important questions to think about. And then once the model is deployed, how is it monitored? Monitoring is a really crucial step in the machine learning operations framework. One of the things that is that again leads to how machine learning projects do fail is this idea that they aren't monitored for things like performance drift or data set bias drift, where if that starts to drift away, it indicates that the machine learning model is no longer performing at the high levels and standards that it should be, and that were expected of it when it was deployed. And so the idea there is we can set up monitors and alerts that help us then go into the final step, which is this automated retraining of the model based on when the model is seen to drift away from its performance. And so as you say, this is a cyclical process. This continues on and on, and it's designed really to help get the best value out of your ML project, really. And so this is where we've netted out with Veracity at the moment. We're in the process of designing this for them, and that's kind of where we're taking the next steps, really, I think. So our next steps with Veracity is to kind of continue to be an ongoing source of support for them. We love working together. It's been a great partnership so far, and we've really seen some incredibly positive results so far. And so our job at Cynozure is to be there as a support, lend our expertise where we can to help Veracity grow their budding team of data scientists so that we can really work together and ensure that we essentially make ML models that are able to beat bot detection in a new way. And so with that, I'll hand back over to Stewart and Sophie to wrap up. Thanks for the attention.
Thanks, Tom. Just to as well. So basically, as I said after the last time Tom spoke, we always approach this as a production model. That's really where we wanted to go with this. And we're an AWS ISV, so that's independent software vendor. So we're a partner of AWS. We're using their machine learning tool set to process data in very near real time, which is something that very few people, if indeed any worldwide, are doing. Mostly AI is about big, coldish, warmish data sets. And that's going well. You know, we're using it in a pre-production environment at the moment. In terms of this new model we developed, it's going to go into production to work with our current ML very soon, to replace our current ML very soon. And we're continuing to work on how do we continue to improve our rapid and accurate detection, because being rapid is important, because obviously we want to find bots very quickly in public spaces because we want to stop them doing what they're trying to do, but also we've got to be accurate. There's always a degree of false positives in these things, but it's how do you balance these two things together. And then expanding from websites into mobile platforms and APIs, as I referred to earlier, and just starting the process thanks to a UK Innovate project that we won earlier this year, which is giving us a reasonable amount of funding to sort of think a bit out of the box in terms of how we might apply this. So we're starting to look at early warning threat protection. How do we get our systems to think like a bot would, to look for the same kind of vulnerabilities that bots are looking for, and also new kinds of vulnerabilities? Where is it that data leakage could mean something? Where is it that, okay, you don't want it to happen, but it's not the end of the world? And importantly, engaging with the market, educate and learn. And one thing I'm personally very passionate about is extending our cyber protection opportunities to all. Most cyber is the remit. Cyber protection is the remit of large organizations who've got a team or an individual at the very least who's got some form of responsibility for cyber. Whereas I think there's something like 99.8% of organizations have a website, and that website could be vulnerable and could leak data, could cause problems for businesses, could result in them going under. And so we're looking at how do we extend this sort of to a wider remit and really turn this into the kind of solution where anybody with a website can use it. And that's really key. And you can see sort of the logos at the bottom there, the kind of organizations we deal with. We did a lot of work with DCIT, Plexel as well, Yorkshire Cybersecurity Cluster, etc. So thank you for your time. I think that's everything.
Brilliant, and a brilliant overview of where it will go in the future. Thank you, Stuart. So we have got time for questions and answers. Just while I pull all of those together, I've seen a few come in whilst you've been talking. So it's obviously a very engaging topic, something that is becoming more and more top of mind for people. There are some useful links that people might want to take away. I'll leave the QR codes on the screen whilst we look at questions. A bit more info about the government survey into cybersecurity breaches. If you would like to feed back into some market awareness around digital artificial engagement, can do that here too. And there is also a link that will take you through to assess the impact of bots on your own website. And then finally, for anyone looking at how machine learning would fit into their own data function, their own strategy, there is a data strategy scorecard that might give you some initial insight on there as well. Okay, so I'll leave those on whilst we look at questions. This is the nerve-wracking bit, Stuart or Tom, because this is more unplanned, but a few that have come in that I'm just looking at. Do you have any recommendations for an organisation that is just starting out on their machine learning journey?
Yeah, I think is that to me. Well, I think I can feel that one. So I think recommendations for companies just coming out on their machine learning journey. That's a really good question. So I think really the thing here is like, it's not to get too focused on. I know we've just spent the last 40 minutes talking about machine learning and AI, but don't get too focused on you must use machine learning and AI from the word go. I think the key thing here is to look for really look for value add projects within your business. Look at use cases that can add value to your business first. I think any decision around doing any sort of advanced analytics should be use case and value driven before anything else. Don't look for the reason to use a shiny new toy like machine learning or AI. I know we want to make use of these new things, but genuinely, a lot of the time, a lot of these solutions can probably be solved without such complex technology. And then if that, if you find that clearly defined business problem, focus on the small things first. If you can't find those business problems, then focus on the small things, getting your house in order, things like good reporting, good framework of KPI reporting, and the good and good data management and quality practices as well. You could say if there isn't really nothing standing out that you think machine learning can answer immediately, then focus on those small things. And then when the good thing then is when the problem does come along, where you can think, oh right, I might need to look at using clustering, or I might need to look at building out a more robust forecasting model for my finances. Then you have the data in the right quality and the right shape to do that. One of the biggest drawbacks to machine learning processes anyway is data quality. I think 90% of a data scientist's time is probably spent wrangling and cleaning data. So the more that can be done, the more that can be, and the more the better the data quality is before you start, the better chance you have of success and successfully implementing a project. I see Stewart had his hand up in my.
Yeah, no, I just want to sort of almost echo that. I mean, the truth of the matter is that for most small and indeed medium organizations, data science is a very expensive activity. You know, data scientists, data engineers are expensive, consultants are. I mean, yeah, they're not. They're real value for money, but it's still an actual cost and a relatively high cost. And when we started out, as you said, very much looking at our data, what could we learn from it, and setting up algorithmic rules first. Yeah, so basically a rule set of behavior, which is quite strong. And, you know, from that came the opportunity to build AI. But the way we started with AI is we started engaging with, it sounds a funny thing to say, but data science interns, data placement students from universities, for people who are on data science courses. They're a good starting point, because what they can do is they can look at what you have and start identifying areas where you might think AI has an application. That's when you start bringing in perhaps, you know, professionals like Cynozure and others, who or hiring yourself, because then you've got a framework, and that's the way we built it, and it's been extremely satisfactory from our point of view. So that's probably a good way to.
Brilliant, thank you both. One potentially for you, Stewart. How can I escalate the urgency and importance of being aware of cybersecurity breaches and bots to my exec team? I think that's in the context of, do we have to wait for a breach for them to understand that this is an emergency situation?
That really is one of those things, isn't it? I mean, you know, it's kind of like any insurance situation, because it kind of is an insurance situation, whereby we're used to looking at, for example, you know, I'm sort of thinking, you know, things like life assurance and home insurance, which, you know, content insurance life insurance certainly isn't compulsory in most cases, depending on your mortgage, I guess contents might be, but they're often not required. But people are used to kind of thinking about those, because they go, well, actually it'll cost me X if I don't do this, or such and such a thing will happen, my family won't be looked after, whatever it might be. And then you have other ones which are sort of regulatory insurance, which car, you know, insurance is so. Although interestingly, if you have enough money and you want to deposit it, I can't remember exactly what it is, but if you deposit it, you don't actually have to have insurance, you just have a huge chunk of money deposited somewhere. I don't have anything like that kind of money. But the point is that we're used to thinking about it in those contexts. So businesses, they kind of do, you know, they do interruption insurance, they look at, you know, personal liability, all that kind of stuff, professional liability, so I should say. And, you know, cyber just sort of seems to be this really weird kind of like unwelcome cousin in the mix, where maybe it's kind of like writing a will, where people don't like to do it because it feels morbid and maybe businesses are kind of like, oh, well, it won't happen to us, or it can't happen to us. Oh, and they've got a raw head in the sand scenario. All I can say is, ahead of, you know, there ever being any legislation that says you must have this form of insurance, if you're going to your senior leadership team and saying, we need to take this seriously, we need a budget to spend on Veracity Trust Network, then what you need to be doing is you need to be saying, cyber insurance is going to get harder to get, which means that we won't have anything to help us if something happens. We probably do have some data that it is that someone might be interested in, or we're doing business with someone they might be interested in, and be clear on who these could be. And then bring some of the stats about what happens to businesses when they're breached, what happens to them. There's plenty of sources of that kind of information around, and just take it in and say, look, we need to take this very, very seriously indeed. If nothing else, from a governance point of view, once you get to a certain kind of size in an organization, you've probably got investors, maybe you've got a regulator, and that's the kind of governance where you can use that to your benefit to say, we don't take this seriously, it's a lot worse down the line if we don't.
Perfect, thank you. And then I guess linked to that, is there a way that they somebody's asked, is there a way that I guess they mean their exec team, assess the impact of bots on their business or organization?
Yeah, good question. Again, I think the starting point is knowing what you know rather than not knowing what you don't know. I mean, I mean, obviously, this isn't a sales pitch, but it's always good to be able to pitch a little bit. The way we approach things is when we work with an organization, we will say to them, okay, let's run a period of time, and it's usually 2 weeks, where we monitor an activity on a client's website and just see what it is bots are doing, where they're coming from, the sources, their geography, but also where they're navigating around a website, which creates a kind of nice picture of, perhaps a potentially unpleasant picture of what bots are doing and where they're going before we start protecting, because measuring that baseline is really important, because otherwise you don't know what you're affecting, you don't know what the true impact is. But that regardless of whether you worked with us, that would always be the thing I'd say you should do first.
Perfect. Thank you so much. And then I've just got a couple more whilst we've got time. What skills, potentially more for you then, Tom, what skills should an organisation look out for when they're looking to hire for their first ML project or their first data scientist?
It's a good question. So I think the thing with data science, as well as Stewart says, it is quite an expensive discipline, I think, to get involved with, especially if a business hasn't got a data science team or even much of a data analytics team. It's a little bit of a costly step up. But I think what I'd say is if a business is at that point in their cycle when they're happy with their data, it's in good shape, they've got a good suite of reporting in place, automated, and they're looking to go to the next step, but they haven't got the skills there. I think that there are 3 things you can do. Probably one of the first things is just to jump right in. You don't need a fully fledged data science team in lots of cases to explore the use of some machine learning methods for some common problems and solutions. So there are, like, for example, the AWS solution SageMaker, Azure's ML machine learning library have a whole range of no code GUI plugins that enable you to essentially drag and drop your data onto various machine learning methods and just see how just to see how they work and experiment with how they work. It may not be the best implementation, but it'll be a start. It'll give you an idea for how your data is suited to be used with that model. And so that's probably one of the first things I suggest to do. The other thing you can obviously do is, again, plugging us a little bit here, is you can work with a trusted partner of experts who are able to help expand your team for you. Like I say, at Cynozure, we have a team of associates who are data scientists, machine learning engineers, and experts really in the field of machine learning and getting those machine learning models into production. That'd be a great way for you to kind of like to step into it, dip your feet in there, and essentially do what Veracity and Stewart did with us. He trusted in our expertise to help get the machine learning modeling journey on the right track. And then, of course, over time, if that's successful, if those outcomes are successful for you, then you might have the opportunity then to build out your team. Stewart and Veracity have started building out their data science team and capability. And again, the trusted partner like Cynozure would be there to help support and help you through that. So I think those are the kind of the three main steps. Say look to experiment with some low no code solutions that aren't particularly expert driven. Maybe look at some expert advice if that's interesting to you, but you're still not 100% sure how to apply it. And the final thing then is once that that starts to prove value for you, then you can look at spending the money and the investment in building out your data science team to make sure it continues to work for you in future.
Brilliant. Thank you so much. And then so the final one that we've got that's come in, which I guess for both of you, is how difficult was this in reality to get into production?
I think it's a tough question, isn't it, really? But I mean, I wouldn't say it was. I mean, the process, it's a journey, really, as we've spoken about it all throughout this session. It's a journey. We've the initial run of this, the initial MVP we built, we experimented with a few things and we got something that was able to move into production pretty quickly. But then we soon realized that as the business evolved, as Veracity's journey data collection became bigger, we'd have to iterate that and scale that again. And so moving it into production using cloud services like those offered by AWS have been incredibly useful and actually made the production deployment relatively easy. But it's what's more important, I think, from my point of view, is about having this framework, this MLOps framework in place to enable that continuous deployment and continuous development of the model, so that we can continually make sure that it's pushed into production on a cyclical, repeatable fashion as and when improvements and iterations are made.
Brilliant. And what was your experience, Stewart?
Yeah, I think I mean, I don't want to go on too long, but I think I just echo what Tom said. I mean, we had an early form of ML in our system for a while now, and then so when we gave Cynozure, we kind of wanted to, we wanted to take it to the next level, as it were, the next version, and we did get into a very strong prototype and then sort of early production quickly, but that was last summer. And this isn't a criticism anyway. It is very much a staged journey. So has it been hard work sometimes? Has it been worth it? Absolutely.
Perfect. And what a perfect way to wrap up. So thank you both for your insight. It's been a brilliant discussion. I've loved hosting it today. And I know that everybody, we can tell from the questions that have come in that it's been enjoyable and it's provoked discussion. Big thank you to you both and to everyone who's joined us. We will wrap for today. Hope it was useful and we hope to see you again soon. Thank you so much.
Thanks so much, everyone.
Thank you.